An agent opened a pull request at 11 at night. Checks ran, it merged itself. No human read it. That is not a demo. Intercom shipped 497 of those in 4 weeks. Across their 2 main code bases, more than 19% of pull requests are approved with no human in the loop. The reason your team does not have that gate is not courage. The missing piece is evidence. A gate merged that code because it read evidence and had a rule for it. Compare that to the default. Of 33,000 agent pull requests studied, 61% got no review at all. 61% is not trust in a system. It is an empty reviewer queue, and the reviewed ones stall. AI-assisted pull requests merge inside 30 days about a third of the time. Reviewer pickup time goes from roughly 200 minutes to 1,055. Review is the bottleneck now. More reviewers will not fix a queue growing at this rate. 6 things have to be true before you can open that gate. Step 1. The score you are reading is partly about your judge, not your system. Automated evaluation started from a solid result. In 2023, Zhang and colleagues at Berkeley showed GPT-4 agreed with human raters more than 80% of the time. That is roughly the rate at which 2 humans agree with each other. The industry read that number and moved to API calls almost overnight. The follow-up work found what the headline missed. Judges respond to things other than the content in front of them. In April, a paper on rubric-based evaluation tested them against criteria a computer can verify. Pass or fail, no taste involved. On the rubrics their own output failed, judges were more than 50% more likely to mark it satisfied anyway. On Health Bench, where the rubrics are subjective, self-preference moves scores by up to 10 points. That is the margin between 2 frontier models. A second study in May measured 20 models on the same setup and found the bias runs both directions. Some judges inflate their own family. Claude Sonnet 4.5 did the opposite and marked its own down harder than any other judge tested, so you cannot correct for it with a constant. You do not know the sign of your own error until you measure it. Length bias rides alongside it. In a June benchmark, 3 judges paid a bonus for longer answers, Claude paid a penalty, and GPT-4o came out flat. Same rubric, opposite instincts. None of that makes the method useless. It makes the setup load-bearing, and 3 rules cover most of it. 1. Judge from a different model family than the one generating. Same family means shared blind spots. 2. For anything high stakes, run a panel across vendors instead of one judge. Averaging across families is what breaks correlated errors, and it costs less than you think. In that same June benchmark, the best agreement per dollar came from a small, fast judge at about 1/10 of a cent per evaluation. 3. Anything objectively checkable goes to code, not to a judge. Did the test pass? Does the file exist? Did the state change? A gate fed by a biased judge is worse than no gate. It launders a guess into a number, and then it acts on it. Step 2. A verdict that does not change the run is a report. Most teams stop 1 step short. They get a number, they put it on a dashboard, and then they ship the same behavior anyway. The shift that matured this year is running evals inside the agent instead of after it. A thermometer reads, a thermostat acts. Each verdict maps to a structural action on the run in progress, not a chart somebody opens on Friday. Low grounding rejects the handoff. A schema failure blocks the edge before the next agent inherits bad data. A suspected fabrication quarantines that branch instead of letting it merge into the main thread. And verified completion is the only thing allowed to end the run. This one is subtle. An agent that stops calling tools has ended its turn. That is not the same as finishing the task. Only an external check knows the difference, and that check has to be code you wrote. This is the first thing the merge gate reuses. A system where verdicts already steer runs has verdicts worth reading at merge time. The teams doing this describe 5 layers. Input guards, tool gating, output guards, a human approval path, and evals feeding all 4 of them. Step 3. Grade the path, not just the answer. Grading only the final response is how an agent reaches a correct answer through a broken sequence that goes unnoticed for a month. Agent evaluation splits into 3 levels, and a real gate needs all 3. End-to-end asks whether the task succeeded. It is the level your product manager cares about, and the least useful for fixing anything. Trajectory level asks whether the path was sound. Loops, redundant calls, wasted steps, and wrong tool arguments all surface here. Component level asks which retriever, tool, or sub-agent broke. It is the only level that tells you where to go and fix something. 3 metrics are enough to start. Faithfulness first. The answer is grounded in what the tools actually returned, not in what the model filled in when a tool came back empty. Tool parameter accuracy. Right tool, right arguments. That is a deterministic check, so it costs nothing to run and it does not drift. And task completion, judged against a real signal. The row exists, the ticket closed. The test that was failing now passes. The failures that dominate agent incidents are not clever model mistakes. Tool call failures, truncated context, runaway loops, silent regressions. Which means the gate you need is not reading English. It is reading a trace. Step 4. Your eval set comes out of your own failures, not a template. Generic off-the-shelf metrics score everything and catch nothing. A helpfulness score of 7.2 does not point at a single line of code. The method that works is error analysis. Sample about 100 real traces and read them, writing a free-form note on every failure. That first pass cannot be handed to a model because the notes depend on knowing your product. Then group the notes into 5 to 10 failure modes. Once 30 or 40 traces are coded by hand, a model can cluster the rest. Then count them. A pivot table of failure frequency is the most honest roadmap most AI teams will ever have. In production, keep every error trace, every timeout, and the top 5% by cost. Then sample 1 to 5% of the healthy ones. That is how you catch drift, because a gate calibrated on last quarter traffic will approve inputs it was not scored against. Step 5. The thing that decides is code, not a model. Rewind published their design in June. A council of a dozen specialist reviewers reads every pull request, each one through a different lens. Correctness, security, testing, performance, whatever the domain demands. Then the findings hit a verdict engine, and that verdict engine is unit-tested code. The model reports, the code decides. Beside it sits a policy file in YAML that a human audits per repository. Auth, secrets, encryption, and governance changes go to a person regardless of what the reviewers concluded. Risk comes from the findings, not from line count. A 12-line migration that locks a large table outranks a 3,000-line generated client refresh. The results. About 40% of pull requests auto-approve. 99% agreement with humans on the ones reviewed both ways, against the bar they set at 90. Under 73 cents per pull request. 0 reverts and 0 incidents traced to a bot approval. And their bot does not push the merge button. A human still owns that, which is the conservative version of this, and it is a fine place to stop. Step 6. The gate itself and what it is allowed to decide. Intercom went further and let the machine approve. The reviewer is split into sub-agents the same way. One checks whether the problem statement is coherent, one checks the diff against the stated intent. Others take safety, logic, and anti-patterns. One traces execution paths through the codebase, which is the part a tired reviewer skips at 5 o'clock. And it refuses. Too large, too broad, too many concerns in one change, and it declines to approve. That pushes engineers towards smaller pull requests without a policy memo. Only the safest slice runs unattended. Another 60% of their pull requests get an AI review that a human then signs off on. Here's the number I keep coming back to. Reverts on AI authored backend code ran at 0.53%. Human authored code, 5.39. On the front end, 0.22 against 2%. Machine written code that a machine approved reverted about 10 times less often than the code we write. I want to be careful with that comparison. AI authored changes are smaller and more mechanical, which is exactly the population a gate should be approving. The rollout was boring on purpose. 100 pull requests in a pilot, 0 reverts, then a wider release. Approval times improved by 6 to 16 times at the 75th percentile. That is where the queue disappears. Every decision is logged and labeled, and they took the whole thing to auditors against SOC2 and ISO 42001. Any engineer can pull a change back to human review at any point. The gate is a default, not a wall. Now the part I think gets misread. On SWE Bench, verified the top models sit around 96%, clustered within a point of each other. That benchmark did not earn anybody merge rights. It measures whether a model can close a curated issue with the tests already written for it. A gate reads evidence. It cannot read intent. Whether the change was worth making at all is still a product question, and it stays with a person. There is a stranger pattern in the data. In that 33,000 pull request study, agents wrote 71% of all review comments, and commands aimed at steering an agent were 16 times more common on agent-authored pull requests than on human ones. A large share of code review in 2026 is machines writing to machines, with a person occasionally typing, "try again." GitHub says more than 1 in 5 code reviews on the platform now involve an agent, and Copilot code review alone has processed 60 million of them, growing 10 times in under a year. The volume arrived before the discipline did. Microsoft measured coding agents lifting merged pull requests per engineer per day by 24%. Meanwhile, the changes got bigger. At the 75th percentile, AI-assisted pull requests run 408 lines against 157. Bigger changes, slower reviews, lower merge rates. So build it in the order that pays first. Start with a tier that needs no judge at all. Test pass, schema validates, types check. The migration is reversible. The diff touches no path on the protected list. That tier is free, and it is most of the value. Second tier, the specialist reviewers. One narrow prompt per concern, from a different model family than the one that wrote the code. Third tier, the verdict engine. Ordinary code with a policy file next to it, reviewed like any other code, because it is. Give it thresholds you can defend. Guardrail recall above 95%, a regression suite of 100 to 500 cases per release. Page a human when the golden set drops 2 runs in a row, when errors triple, or when cost per user jumps 5 times. Then run it in shadow mode. Let it decide and log, while humans still approve, until you can show agreement above your own bar. Rewind set that bar at 90% and shipped at 99%. You can run that comparison before you risk anything. The failure mode to watch is a gate that approves everything. If your auto approval rate climbs while your revert rate stays flat, you built a rubber stamp with a dashboard attached. This work has a name now. Eval Engineering owns the datasets, the score logic, the CI gates, the production sampling, and the regression tracking. It is a running system, maintained like any other production service, not a document you write before launch. The end state is not a model you trust. It is a gate you can read, argue with, and switch off. Intercom and Rewind both published their designs this year, and the parts are ordinary. The order is what most teams have wrong. Build the evidence first. The permission follows it.